Okay, so very good afternoon, all of you. This side Kuldeep Dikshit from Shape My Skills Private Limited, Noida branch, and I am working as a marketing head over here. So, as you know, today we are here to organize a industrial conclave 1.0, a guest lecture series by the industry expert for technical enthusiasts. So, as you know, today we are here to session on artificial intelligence. So we are here with our faculty, Mr. Rahul Pathak sir. They are having more than a 10 year of experience in data science. So over to Rahul sir, you can start your session.
Hello, Kuldeep sir. Good evening. Good evening to all the participants and viewers who are watching. So I would require just 1 minute to share my screen and get the system ready. And once you all can see my screen and I have the typing commands, the ID is open, we can, straight away jump and start the session. We can begin with the technical details. Okay. So just 1 more minute. Just give me 1 minute so that I can get everything ready. Right, so I've enabled the screen sharing option and let us, straight away jump onto the IDE that we will be using for our hands-on webinar that we are going to have today. So this is the Spider IDE and we are primarily going to work with it. So I'll open a fresh file for you. Control N and let us remove everything from here. Let us call it webinar.py. And let us also increase the font size so that it is visible and we can write down the necessary details that we want to work with. So today the topic that we have selected is artificial intelligence. And this will be a hands-on webinar, not like the webinars that mostly contain only the theoretical aspect of a topic, which have PowerPoint presentations with illustrations and figures. So today what we are going to do is we are not just going to discuss what artificial intelligence is. We are actually going to solve a real world problem with artificial intelligence. We'll see how AI can actually tackle the most difficult and the most realist of the problems that is faced currently by humanity. So the example that I have created for you is that right now we all know that we are living in the world of a pandemic. I mean, Corona has done a lot of damage for each and every country, for humanity, for each one of us. And the main purpose of artificial intelligence is that how can we use mathematics, how can we use science, and how can we primarily use computer science to solve all the pressing issues that we have, right? So anybody who knows anything about artificial intelligence, he will know that it is a buzzword. A lot of industries have started using AI. So whether you talk about national security or whether you talk about food delivery, each of these applications and each of these tasks do require AI to serve their customers better. So we use artificial intelligence to protect our borders also, and we also use artificial intelligence to find out better routes for our delivery boys so that your pizzas and breads can reach in record time and they are hot and they are fresh, right? So no matter whether we are talking about banking industry or whether we are talking about the healthcare sector, we are talking about commercial airlines, AI is everywhere. And glitch with the internet connection. So I have reinitiated the screen sharing option, and we'll wait for a second so that our participants can, confirm that they can view the screen. So, beginning with the chain of thought that I left for you, and the chain of thought that we were talking about is that the reason why AI is important is because it is used in each and every sector. It is used, for protecting our borders, for defense. It is used in the banking sector to make the transactions secure, to avoid credit card fraudulent. It is used in, food services, Zomato and Swiggy, to make sure you get the best route and so that you receive fresh food. It is used in healthcare sector to, diagnose diseases, early signs of diseases, so that we can warn the patients and they can purchase a health insurance and be protected, right? So today, as I mentioned in the beginning, there were very few participants at that point of time, and I think we lost a connection also. So I'll reiterate this point for you. So as I was mentioning in the beginning, this particular webinar, we are going to do a hands-on exercise. Okay? So we will actually be solve a pressing image processing task that will help us in understanding how real-world AI systems are created. And we can then use this example to map it to the real world data and actually create systems which can be deployed, right? So I was beginning with the chain of thought that right now we are living in the world of a pandemic. Everybody knows that Corona has kind of affected our daily lives. A lot of people who were not very fond of using the internet and online services, they had to come to internet because there was no other option left for them, right? And for us also, we are doing a webinar. So who better than us to understand this thing, right? So we all know that COVID is a disease that has been, taking a lot of lives, and a lot of people are getting affected by it. And primarily what COVID does is it kind of creates an infection in your lungs, right? So if the doctor can do a CT scan, the CT scan is done on the score of 25, he can find out how much lung infection you have had, how much effect COVID has had, or how much effect the virus has had on your lungs, on the basis of your X-ray and on the basis of a CT scan, right? On the basis of that, he can start with you on a medication. So if you will give you high-powered antibiotics, and he will start you on a different course, right? But if you have lower level of chest infection, certainly he'll give you very basics of medicines, right? So far, the thing that we have as of now, or the technique that we use as of now, is that when we have an X-ray image of a person's X-ray, we actually need a doctor to diagnose what is the information present in the X-ray. But you know that the ratio that we have in the real world is that we have one doctor for 20,000 people. So it is almost impossible for, to get a doctor so that a doctor can inspect the chest X-ray images for each and every person. In fact, it is very difficult to get an X-ray for each and every person if a disease like this has been spreading its arm, right? So how AI is going to play a role in this particular game is that, let's say that you have a report, and it is very easy to do COVID test because we have the RT-PCR mechanism there. And let's say by using that test, you kind of confirm that you are diagnosed with COVID. Then you kind of feel the symptoms of infection, and you go on, get a CT scan, get an X-ray, right? So you don't actually necessarily need a doctor to infer that X-ray or to read that X-ray. We can actually use an artificial intelligence system. We can use an AI system to read the X-ray for you. The subset of AI that will do this for you is primarily known as image processing, because X-ray is nothing but an image. It will have pixels depicting the infection that has occurred in your lungs. And basically by using image processing, we can kind of read the X-ray report and give you a proper prevention, give you proper medication. We can find out how much effect there has been on your lungs. Okay, so the project that we are going to create today, and I have some real world data set for you. It is very minimal in size, because in healthcare, what happens is you can't really get very large data set unless and until you are employed by a hospital itself. Okay, so the data is quite confidential. So we have a small subset of data set that has been scraped from open source sites or research communities. We will use that data set to kind of create a system like this. So what we are going to build in today's webinar live. So I don't really believe in showing my participants pre-written code. Otherwise, it kind of becomes pointless. It is very easy for me to pre-create a Jupyter notebook file and simply run it for you. Okay, I don't believe in that paradigm. So what I'll do is I'll try to write each and every piece of code with you parallelly, simultaneously. Now I know that most of the speakers or most of the viewers who are here in this webinar might not be fluent with Python. We are primarily using Python to implement this thing. If you want, you can use R language also. We use Java and C++ also to create AI systems. That's a language independent technology. So if you do not know Python, do not fret, do not worry. I do not expect you to know the syntax structure by heart, but what I do expect is that if I'm running a piece of code, I want you to understand what is the effect it has had on the data set. Okay, so what we are going to build today is that we are going to build a chest X-ray image recognition system to diagnose COVID positive patients. Diagnose COVID positive patients. COVID positive patients. This is what we are going to build today, right? And certainly the prerequisite for creating a project like this. So I'll write it down here. What is the prerequisite? So prerequisite for creating an application like this is that you must have data. And when I say data, you must have, chest X-ray images. You must have chest X-ray images of COVID patients. COVID patients. Only then you can train your system to find out that, okay, if this much infection is present in an X-ray image, there are symptoms or there is an indication that a person is affected by COVID, right? So now what I'm going to do is I'm going to give yourself a snapshot of data. I'll minimize this window, and this is my desktop. Okay, take a good look at it. If you have a look at my desktop, you will see that there are two folders here on the left-hand side, and there's a folder here called COVID folder, right? And then there is a folder here called normal folder. Just a second, I'll show it to you. Yeah. So we have the COVID folder and then we have the normal folder. If I open these two folders for you, these two folders actually contain 100 actual X-ray images for people who are suffering from COVID and the people who are normal. That means their lungs are normal. So if I open this folder normal, you can see these are normal X-ray images that I have, right? I can maximize it for you like this. Yeah. Have a good look. I'll wait for a second here. Right. So I have given you, few minutes to have a good look at this data set. Now, if you will again notice, you will see that since these are real world chest X-ray images, what has happened here is that all these images are present in different dimensions. That means, that each and every image is nothing but a collection of pixels width into height. So if you have a good look at it, some of these images are in portrait format and some of these images are in landscape format. They have different dimension, and that is how the real world data is. It is not unique, right? And it is not in accordance with your particular dimension. Now, if you open the COVID folder, you will have a look at, now we have, data of people who are actually suffering from COVID. Their lungs are affected. And to show you the dichotomy here, what I can do is I can open one image. I can maximize one person's image who is suffering from COVID. And I can maximize one person's image who is, not suffering from COVID, to show you how the chest X-ray images differ. So see, this is one normal person. Let me show you the dichotomy of it. This is a normal person's X-ray, and this is the X-ray of a person who is actually affected from COVID disease. You will see that the person who is actually affected by COVID, his lungs are cloudy. It's more light textured. The X-ray is more light textured. So it is very easy for us to also find out just by looking that, okay, we don't really know the indications that there are, but it is very easy for us to distinguish that, okay, this X-ray image looks kind of clear, crystal clear, and the bones are visible, is the normal person's X-ray. And here, where the bones are not quite visible and cloudy shape is there, so certainly this is a person who has lung infection, right? Now, In this folder also, in the COVID folder also, you will see from here, you have images in different dimensions. So if I highlight it for you, and if I move from one image to another, you will see that height and width is changing. That means the dimension of each and every image is different, right? The data is not uniform, and the data is mostly not uniform in the real world. That is the problem that we have to tackle being an AI engineer, right? So I'll close it for you. Now, when we are trying to make this application, or when we are trying to make an AI system that can recognize these images, the first and foremost task is to actually import these images. You need to have these images in the Python context, only then Python can work with it, right? So I'll write this project and I'll create this project task by task by task, right? And whenever we start with a new application, you know, be it C language or be it C++, be it any language, we always first import a set of libraries, right? So I'm going to now write some Python. If you are good with the syntax structure, that's very fine. After the session, we can have a QA section also for a few minutes. So you can ask what a particular syntax does. I'll help you with it, right? So there is a library called NumPy. We'll import it. NP is the shorthand. We will import a plotting library, matplotlib, which will actually help us in plotting the images. Then we will import a library called pandas, right? Now in Spider, what happens is you can select these statements and hit a control enter, and this is where your execution happens. So this place is called the editor. That means the left hand pane, and bottom right hand section, this section is called the console window. So whatever you write in the editor, it is actually executed in the console window, right? So we have NumPy, matplotlib, pandas. We do need some more libraries. So we need a library called glob, GLOB. It is used to read large data sets. And then we need a library called CV2, which is OpenCV, and it is used for image processing, right? So we'll take these two libraries and we'll hit a control enter. Now this is a section that I want you. This particular section tells you what are the variables which are there in your RAM, that is in the primary memory, and you can see it is empty. So the first thing that we will do is that we will read those images, all the images which were there in the COVID folder and all the images which were there in the normal folder. And to reiterate this fact, I will open desktop here. Please pay attention that the COVID folder has how many items. You can see on the bottom left hand section where my cursor is floating. So there are 100 items. That means we have 100 such X-ray images here. See where my cursor is floating. And if you go to normal, you will again see that this normal folder it has around 112 items, but some of these items are not images. You can see this is a paint window and these are all paint windows. So it also has around 100 images only. So what we'll do is we will first take the unnecessary images out of this folder. We don't want it. Okay, it is good to have data in a standardized format. So we'll take these images, Control X, and let's paste them somewhere else. We don't want the path to coincide with each other. And you one more time go to the normal folder, and there's one more image here. Control X, remove it. The reason why we are removing it is because this is not an image of X-ray. Right? Now what we'll do is we'll try to read these images, and I want you to notice the syntax structure that I'm using. So I'll use something called the list comprehension, and I'll write it for you. So the syntax that I'm using is using a list comprehension. I'm writing for file in glob.glob. Now inside glob, we will pass the path that we have. You can see that the current working directory that I have is desktop here, where my cursor is floating. That is top right hand section. It is C users, Rahul Pathak, and desktop. And on my desktop, there is actually a folder called COVID. The C is capital here, right? So you come down here and you write down that I actually have a folder called COVID, give a slash and write down *.jpeg. It means that all the images in the COVID folder which have JPEG notation, and asterisk means all the images. You can import one or two images also if you want. Asterisk simply means that all the images which have .jpeg notation. Now, if I run the syntax structure by returning file, I want you to see what happens. Control enter. So when I run this, I want you to notice the bottom right hand section. You can see that it has returned the path of all the images. The window that I'm sliding on the bottom right hand section, right? So this is the path of all the images. And once I have the path of all these images, I can simply read it by using the imread function. Imread stands for image read function. So what I'll do here is I'll write down CV2.imread. Imread as an image read. Wonderful. And now you can store this output back to a variable. Let's say that variable is COVID. So when I'll run this, you will see all these 100 images. Now you can see that all these 100 images are here, top right hand section in a variable called COVID. And if I double click on this variable, give it a second to open, you will see these are all the 100 images, right? Their notation is given here. So each and every image is in different dimension. You can see the first image has a dimension 650 by 128 by 3. So 650 is the width, 128 is the 1028 is the height, and 3 basically is the number of channels. So images are usually represented in 3 channels, that is red, green, blue channel, RGB encoding, right? The second image has a notation of 485 by 855 by 3. The third image is 13101646 by 3. So this is how you can see 100 images have been imported, and all these images have different dimension, right? So what we can do is, by using the same syntax structure, we can import all the normal images as well. So you basically do a Control C here and a Control V here and store this in normal. Just change the COVID folder here to the normal folder. We have seen that the normal images are in the normal folder, and you repeat the same syntax structure. See what will happen. Give it a second. So you can see now I have 2 variables. These are the normal images. Okay. So the first task is done, that is to import the data set. So we have the data set in Python now, and I'll write it for you here. Proper documentation so that it is useful for you. So importing the libraries. And here you write down importing the data set. Importing the data set, right? Now, once you have the data set, certainly we are going to do visualization. So you write down visualization here. And for visualization, we can again use CV2, which is the image processing library. Okay. So I'll plot the first image, and we know that in programming, we start counting with a 0. So certainly the first image will be at the index 0. If there are a total of 100 images, the indexing will be from 0 to 99. Anybody who has read anything about computer science knows how the indexes work. Okay. So I'll plot the first image for you, and I'll show you how we can use Python for plotting. So you come down here, you write down CV2. And this time you call the 𝐼𝐾 function. Again, 𝐼𝐾 stands for image show function, right? You write down first, and then you write COVID, which is your array, and give the number 0. Right? 0 means the first image. CV2.wait key. We don't want it to wait for anything. Put 0 here. And then CV2.destroy all windows. This is to destroy all the previous plotting windows. Now, when I will run this piece of code, you will see that a new window will pop up. And this will basically show you the first X-ray image. Can you see? I'm pretty sure you can on your system. So the first X-ray image has been plotted by using the Python syntax structure, right? By using the Python language, right? And you can see that this X-ray image is quite large, so it is not fitting my screen, right? And I can also show you the first normal person's X-ray image. You simply take the same syntax structure, Control C, hit a Control V. In place of COVID 0, sorry, you write down normal 0. Run this piece of code. So this is the first person's X-ray coming from the normal folder. That means the person who is not affected by COVID. Again, you can see that when Python has plotted this X-ray, it is kind of exceeding the screen size, right? And we have seen this, that the images that we have, they come from different dimensions and different notations, right? Now, after visualization, one major challenge that we have is data pre-processing. So after visualization, what we'll do is, I'll write it down for you. We'll do data pre-processing. And the most important pre-processing step that we want to do is, we want to resize the images, resize all the images in a common format, Now, this common format could be anything depending upon the RAM and depending upon the processing size you have. Control S. So if you open these 2 folders, you can see these are quite large images, not fitting my screen. I'll choose a small dimension. For example, you can see this image has a dimension of 1152 1264 by 3. That means 1152 pixels in width, 1264 pixels in height, and 3 is the channel. I'll resize it down to a smaller number, and you can resize it down to any number you want. Okay, that is not something that is hard coded. So let's say the dimension that we are choosing, the dimension that we have agreed upon, I want to resize all the images in the dimension of 300, 300, 3. Right? That means 300 is the width, 300 is the height, and again 3 is the channel. So for this also, I'll use the same syntax structure. Right? I'll write for image in COVID. This is a loop which will basically go to this COVID variable and one by one iterate through images. You take this image out and you use the resize function. So you write down cv2.resize. Again, quite simplistic language Python is. So if you want to do resize, the code for that is resize only. And after image, you also provide the dimension in which you want to do the resizing. So I'm providing the dimension 300, 300. Okay. Now you can take the same syntax structure, Control C. We will resize the normal images as well. So in place of COVID here, write down normal. And we save these resized images back to the original data or back to the new variable. So we are calling it COVID data and we are calling it normal data. Normal data. Okay. Now I want you to notice what happens when I run this piece of code. Hit Control Enter, wait for a second. So you can see that now two more variables have been created. I can highlight it for you like this. See, now all the images have been resized into the same format. Each and every image is 300, 300, 3, right? All the images are in same dimension. And also for normal data, each and every image follows the same dimension, 300, 300, 3. So this time when you will do the visualization, I can copy and paste the same syntax structure, Control C. Earlier, if you remember, the X-ray was going out of the boundary of my screen. But because we have resized it into a smaller dimension, this time it will fit my screen size. I want you to notice it. So when you run this, you can see it now short, sweet, concise, and simple, a very smaller notation of X-ray that we can use for visualization purposes. This one is for COVID patient, and this one is for normal patient, because we have resized it down to a smaller dimension. It is comprehensible, it is accessible, it is understandable. Okay, wonderful. So resizing and data pre-processing is done. Now, resizing is not just the only data pre-processing operation we have. There are certain other operations as well. So far what has happened is that COVID data and normal data are stored in different variables. Now what we'll do is that we'll create a master data set and we will store both COVID images and normal images into the same variable. So we'll write down that let us store, let's save both the COVID X-rays and the normal X-rays in a single master data set. A single master data set, right? So this is the next task that we have. And for this task, I will basically do concatenation, right? So you take COVID data, change its nature and make it an array. Currently, it is a list. You can see it from here that the type is a list. We will make this into an array because arrays are easily concatenatable. Okay? So it will be easier for us to concatenate array. Control C, Control V. In place of COVID data, write down normal data. And here also in place of COVID data, write down normal data. Okay? Now, when you will run this piece of code, you will see that the type here has become an array, right? And the dimension is 100, 300, 300, 3. Notice where my cursor is. So 100 is basically the number of images, 300 is the width, 300 is the height, and then 3 is the channel, red, green, blue, RGB. Okay? Now we'll apply concatenation. So you write down here that capital X is the variable, which is the master data set. And you say np.concatenate. You can see I'm using automatic suggestion, not writing most of the code. And while doing concatenation, we have first taken the 100 COVID images, and then we have taken the 100 normal images. Now, when you will run this piece of code, see what will happen. A new variable X will be created. Now its dimension is 200, 300, 300, 3. Notice where my cursor is, top right hand section. That means a total of 200 images, same width, same height, same channel. Right? So this is how we have created the master data set. The next process is called label generation. Label generation. And I want you to really understand what label generation is. See, we know that COVID images and master and normal images are separate because we had a data set that separated COVID images from the normal images, right? But the algorithm will not know it. So we need to create certain labels to mark COVID images and normal images. Full stop. The AI algorithm will use these labels, learn the differences between a COVID image and a normal image. Now these labels could be anything. The rule of labeling that I'm going forward is with that for COVID images, that for COVID positive images, I will assign a label as 1, and for normal images, I will assign the label as 0. Okay. So it becomes a binary classification task. You basically have to separate ones from zeros, right? Now this label could be anything. You can take the label as 201 and 202. You can take the label as 317, 476. Doesn't really matter. You just have to create separate labels for COVID and normal. So now we'll do this programmatically. So you see what I'm doing here is you create a variable called COVID label, right? And you write down np.ones. How many ones do you want to create? 100 ones. Why? Because we have a total of 100 images of COVID patients. And then you write down as normal label. And you do np.zeros. Right? How many zeros? 100 zeros. Run this. So basically this is COVID label. That means 100 ones. And this is the normal label. That is 100 zeros. Right? Like how we have concatenated and created a master data set, we will create a master label. So we will create small y, and in small y, we'll again do np.concatenate. And this time in concatenation, we'll again take COVID label, like how we took COVID data, and we'll take normal label. Right? Now, when you will run this, you can see that a new variable y has been created. So y will contain first 100 ones because these ones mark the first 100 COVID images. And then it will contain the rest 100 zeros because these zeros mark the 100 normal images. So the data is ready, the input is ready, and the output is ready for us. Okay. Now the next task is we will shuffling the data set and splitting it into training set and the test set. Okay, so we'll use the training set for training the algorithm, training the AI algorithm, and we'll use the test set to test it, to test the AI algorithm. Okay, and we'll also perform shuffling. Right now, how will we do that? We'll do that by a function. So we'll write down from sklearn. Sklearn is scikit-learn, which is a machine learning repository. We'll call model selection. After model selection, we'll import a function called train test split. Inside train test split, I will provide capital X and small y, capital X being the images, small y being the label. And X will be divided into two parts. It will be divided into X train and X test. And by default, the splitting ratio is 75:25. So 75% of observations in the training set and 25% of observations in the test. When you will run this, see what will happen. I want you to notice the changes. 4 new variables would be created. So notice here on the top right hand section, this is capital X. Its dimension is 200, 300, 300, 3. That means total 200 images. Now in X train, we have 150 images. That means 75% of 200. So 150 images for training. And this is X test. If you can notice where my cursor is floating, it has 50 images. That means 50 images on which we are going to test our system, right? And also shuffling has been performed. So if you notice Y train and Y test, sorry, this time you will see that ones and zeros are intermixed. Earlier, ones and zeros were continuous in nature, but since we have performed shuffling, now ones and zeros are shuffled. And now I can show you the visualization of the entire data set. You do a Control S, visualizing the training set. Visualizing the training set. So I can show the training set to you something like this. I'll write a loop. Let's say for I in range 25, let's say I want to show you 25 images. You write down plt.imshow. That means the image show function. And in fact, before imshow, you take subplots. And inside subplot, you pass the range as 5, 5, I plus 1. Come down here, pass x text. We don't want to assign text. plt.ytext. Don't worry about the syntax structure, just pay attention to what is actually happening and what is the result that we get when we execute it. Then you provide the imshow function. Now inside the imshow function, what we'll do is we'll take x underscore train and we'll print the first I images from X string, right? We want the first I images, and we also want it in the grayscale format. So put gray here, and then you put plt.show. Ready? Now, when I'll run this, see what will happen. A new pop-up window will be popped up, and you can see that these are the first 25 images from the training set. Since we have performed shuffling, now it contains both COVID images and real images. And how I can show it to you, you can associate a label here. So you can write down plt.label, and inside the X label, you can have 𝐲𝐼𝐻𝑇rain. You can have 𝐲𝐼𝐻𝑇rain I, right? And let's have a tight layout, plt.tight layout. And now when you will run this, give it a second. Wonderful. So you can see that ones and zeros are marked at the bottom of the images, where 1 means that it is the X-ray image of a COVID patient, and 0 means it is actually the X-ray image of a normal patient. If you want, you can interchange 1 and 0 with the actual label. So I'll do that for you also. Let's make it more beautiful, right? So here you can write it down, that give it a small identifier, write it down as label. After label, you use string formatting, call the dot format function. Inside the dot format function, provide 𝐲𝐼𝐻𝑇rain I. Now, this is a simple Python structure, okay? You don't have to worry about it if you are not very good with Python. So now you can see that at the bottom, not just ones and zeros, but before 1 and 0, there is actually a syntax structure called label that has been written, right? Now, if you want to use the English language terminology, I can show it to you how you can do that. So you create a new list here. See, create a new list here and write down 𝐲𝐼𝐻𝑇rain name. 𝐲𝐼𝐻𝑇rain name. And you provide it with a list comprehension. In this list comprehension, write down that if I is equal to 1.0, you assign it the label COVID positive. You write down COVID positive. The COVID positive is I is equal to 1. Else, you assign a label normal. You can assign a label normal, or you can assign a label as healthy, whatever you see fit. So write down normal here, and do this for I in 𝐲𝐼𝐻𝑇rain. So I want you to see what happens. When you will run this piece of code, a new variable 𝐲𝐼𝐻𝑇rain name will be created. This is 𝐲𝐼𝐻𝑇rain 1 and 0. This 𝐲𝐼𝐻𝑇rain name basically simply contains the same information, but in place of 0, you have normal. In place of 1, you have COVID positive. And I have opened both these variables simultaneously side by side for you so that you can have a good look at it. Okay. So basically the same thing, but written in textual format, right? Now we can use this 𝐲𝐼𝐻𝑇rain name so that it looks more beautiful to us. Close it and close it. You come down here, in place of 𝐲𝐼𝐻𝑇rain, you write down 𝐲𝐼𝐻𝑇rain underscore name. And now when you will run it, you can very easily visualize the training set. So this is the training set that we have. You can see that some of the images are normal, some of the images are COVID positive. The data set is shuffled and is actually ready for the algorithm to work with, right? So you close it. And the final step that we have is that now we are going to reshape the data and make it ready for the algorithm. So we'll say reshape and change the data into 2D so that a machine learning algorithm can work with it. And how will this reshaping happen? How are you going to reshape 4-dimensional data into 2-dimensional data? It's pretty easy. So you come down. Right now, the dimension that you have, if you have a look at X train, or if you have a look at X, the dimension is 200, 300, 300, 3. Okay. So this is 4D because it has 4 components. When you will change it into 2D, you simply need to multiply the variables 300, 300, 3 into a particular value. So if you do 300 here into 300 into 3, you can run it. You will basically get 270,000, right? So you close it. You can change this into a dimension of 200, 270,000. right? This is how you change 4-dimensional data set into a 2-dimensional data set, right? Now we'll perform the same operation on the training set and the test set. Pay attention. So we'll take xtrain, call the reshape function, and in the reshape function this time we'll write it down 150. Why 150? Because training set contains only 150 images, and then 270, 1, 2, 3, and we'll do the same thing for the test set as well. Control C, you come down here, hit a Control V. In place of xtrain, put xtest as well, and in place of 150 you put 50 because training set contains only 50 images, and we want the output to be reflected on the original data set. So make sure you put the output on the original data set. Now when I'll run this, I want you to notice what happens. See, now this is your xtrain, its dimension has changed. It is now 150, 270,000. All these 270,000 are nothing but pixel values. And xtest is 50, 270,000. Again, these 270,000 is nothing but pixel values. And now we will train an algorithm onto it. Okay. Now we can use a couple of algorithms, but I'm going to use an algorithm called the random forest algorithm. Let's apply random forest algorithm application. Okay. So I'll call the random forest algorithm for you. Now, random forest algorithm, the mathematics for it is, quite right, guys. So there was a little delay. Apologies for that in the internet connection, and now everything is back online. So what I was telling you that the mathematics of random forest is pretty complicated, and we actually have to read a lot of statistics to truly understand how random forest works. But the good thing about AI is that these algorithms are pre-created in libraries, so you can straight away go and use them, right? So we'll import the random forest algorithm. You can see that the automatic suggestion is working. Write down RF is equals to random forest. And inside that, there are certain parameters that I'm going to work with. So there's a parameter called max depth that I will be using, and I will be associating it with 10, taking RF, fitting it onto the data set. So write down xtrain, ytrain. Now, when you run this piece of code, this random forest algorithm will have a look at your data set. And right now the code is executing because this particular red box is here. And you can see it has done execution. So once it has done execution, you can simply call the score function to get the accuracy on the test set. So you write down x score, xtest, ytest. And on the test set, the accuracy that it gives, you can see here is 0.9. That means 90% accuracy. That means if there are 10 images that it is predicting, 90% of the times the prediction will be correct, right? But how are you going to visualize the predictions along with the actual labels? For that, you will have to get the predictions eventually. So you call rf.predict function from here. Inside the predict function, you pass xtest like this and store the output back in a variable called ypred. Ypred means y prediction. So basically for test data, this is ytest. I'll open it for you. These 50 are actual labels of the 50 images. And this is ypred. These are predictions. So you can see that in the starting, most of the predictions are actually matching the actual values, but there are some predictions which are incorrect also, right? Now, how are you going to highlight it? I can highlight it by using visualization techniques, something like this. So we'll take ypred and we'll change its name take the syntax structure here. Again, we're simply changing ones and zeros to image names. Okay, normal and COVID. You write down y underscore pred underscore name, and here you write down y test because we are working on test set. Now, when you will run this piece of code, so basically, again, this is ypred 1 and 0, and ypred name is nothing but the categorical or string alternative. Wherever you have 0, there will be normal. Wherever you have 1, there will be COVID positive. And now I'm going to show you the final output where each and every image along with its actual label and predicted label will be shown. So the final step is, document your results. Document your results. And I'll show you how, documentation works, how documentation of result works. So you take the same syntax structure that I have only written. Because I have written, I can copy it. You take a control C here, put a control V, but this time pay attention. We are not going to print X train I, but X test of I. That means we are taking the test set, X test of I, right? And the label here, we are going to associate two labels, the actual label and the prediction. So you write down here, actual, and you change the line /n, and then you write down prediction. Actual and prediction. Okay. Now, since there are two variables here, you should have the names of two individuals passed in this particular section. One is the predicted name and one is the actual name. So again, copy the same syntax structure, control C, control V, and write down y test name here. And simply in place of ypred, write down y test. Run this piece of code. Done. And now in the format function, first you have the actual value. So in place of y train name, you put y test name I, and then you have the predicted value. So for predicted value, what you are going to do is you are going to take y pred name here, y pred name for the ith index. Now when I will run the piece of code, I want you to notice what happens. Control enter, and we need to resize the images also. Because we have flattened, it is showing an error. You can see it says invalid shape. And the reason why it is saying invalid shape is because earlier the data was here 4-dimensional. Now it is 2-dimensional. So not to worry, you simply go here and call the reshape function. Reshape it back to the 3-dimension so that we can visualize it. Now when you are reshaping it inside the reshape function, don't forget to pass the actual argument. So the actual argument would be 300, 300, 3. Right? And now when you will run this piece of code, give it a second. Yeah. So you will have all the images here. So this is basically your final output. You can see that from the test set, that means the data that the algorithm has not seen, these are first 25 images along with their actual label and along with their predicted label. And because the accuracy of the system is 90%, you see that most of the predictions are correct. If I want, I can play with the accuracy. It is possible to tune the accuracy to increase from 90% to 95% to 100%. It is also possible to decrease the accuracy, right? So random forest is not a very sophisticated AI algorithm. We can use, convolutional neural nets. We can use recurrent neural nets. We can use, use other deep learning techniques also. We can use sophisticated image processing techniques also to make the system work better for the real world. But this is how you actually create a project by a test data. You can take the same framework that I have used and you can replace it with the real data. You can replace it with a big algorithm or a complicated deep learning algorithm, and this real world system will be ready at your disposal. You can see that out of these images, few predictions are incorrect. For example, I can put my cursor here and tell you that the last image of the second row has incorrect prediction. Actually, it is a normal image, but our prediction is COVID positive. So we know that 90% accuracy, definitely in 10% cases, we would get incorrect prediction also, right? So this is the complete small system that I have created for you. You can see it is quite easy. And in just about 121 lines of code and in about 60 minutes of time, we have actually used AI to solve a real world problem, right? Now I'll give you a couple of examples of how we can use data to create applications like this. Okay. So whenever we talk about smart applications, this is exactly the paradigm that we use, right? So you write the word here, smart applications that you use on day-to-day basis. So we have all have heard about Alexa. So what Alexa basically does, it is nothing but a voice assistant. It is a voice assistant, right? And to create a voice assistant, the data that you need is that you need the data of natural voices. Okay, only then you would be able to distinguish between the voice of Amitabh Bachchan and the voice of Sachin Tendulkar, the voice of the speaker and the voice of the guest. Apart from Alexa, we all have heard about systems of weather forecasting. We all have smartphones, right? And we see that that particular system is able to tell whether the weather is going to be rainy or is it going to be cloudy. And obviously for creating such systems, we need the data of weather, right? Apart from this, we all have worked with smart chatbots. And if you want to create any kind of chatbot, be it Twitter chatbot or Facebook chatbot, you need the data of conversations. You need the data of conversations. We also know about the sentiment analysis systems that kind of find out hate speech content that Twitter and Instagram use for marking a particular text as hate speech. So for that also, we need the data of texts, okay, or actual Facebook post or actual Twitter tweets. Apart from this, there are certain other systems. So we all know about facial recognition. We all know about facial recognition. We have seen it in Hollywood movies. It's quite easy to create. In order to create a facial recognition system, you can use the same example, you can use the same project, just replace it with the data of human faces. Okay? So etc, this list is endless. Each and every time you can use the data from real world, you can apply some mathematics onto it, you can apply certain image processing, certain natural language processing, certain statistical techniques, certain significance test, certain exploratory data analysis measures, ETL, extract, load, transform, and finally you will be able to create a system that can serve your customers, that can actually solve a real world problem, right? So in about 130 lines of code, we have completed our webinar, and I'm pretty sure you guys must have learned something. If you want to know a lot about these project details, certainly the code will be shared with you. You will get each and everything in the description of the video that is shared with you. And the guys at Shape My Skills, who are a premier at organizing technical trainings, these guys have a lot of connect and a lot of reach in the real industry. They are connected with all the people who are working in the real world. So certainly they have a very populous network. So if you are also the part of that network, you will leverage its advantage. Thank you for being with me. I hope you like the session. And now I will stay connected for the next 10 minutes as well, so that if you have any question from the field of AI, from the field of data science, from the field of machine learning, you can put forward in the chat window, and certainly I will answer as I'll seem fit. Okay. Thank you guys. Thank you for being with me. Enjoy your weekend. I'm here for 10 minutes for QA. Right, guys. So I can see a couple of questions in the chat window. Let me take all the questions one by one. So Vishal Singh has written, can we get the code file? Certainly, Vishal, you will be shared the code file with, do not worry about it. Otherwise, you can also take a screenshot of the freezing screen and reproduce the code yourself. Okay. Crazy Girl NJ has written, it looks like RStudio. Yes, RStudio actually is an IDE that comes from our language. Spider, because it is a new IDE, so the motivation to create Spider was coming from RStudio only. So yes, it does look like RStudio, right? It's a product that has been inspired from RStudio. Great. Vishal Singh has written, sir, how do I get the image? Any source? Yes, Vishal, the source is kaggle.com. Okay. Kaggle is a site. You simply need to search KAGGLE on Google. On Kaggle, if you write down COVID X-ray images, you will be, shown a lot of repositories that contain the images, and you can simply click the download button and download it. Just remember the name of the site. The name of the site is Kaggle. Vishal saying, any sources where we get the images? Same answer, Vishal. You can, get the images from Kaggle. And one more thing I would like to, inform each and every one of you, like, see, this is a webinar and we all know that not a lot of attention is, or not a lot of motivation is there when the webinar is going at a certain pace, or if only PowerPoint presentations are shown to you, which is why I have tried to, write the code with yourself so that you can see that actual code has actual impact, and how we are going to change the data, how the change data is fed to AI system, and how actual predictions are getting generated. But you need to understand that this is a micro example. Okay, you only understand how AI is working by this example, but this is not how you actually create real world projects. Real world AI projects have a timeline of 6 months to around 1 year. It's not that easy, I need to tell you that. Okay, but when you will be working in companies, this is exactly what you will be doing, but the time window will be greater and the data will also be much more larger than this. You won't just have 100 images, right? And for that, there is a closely coupled technology that we use with AI. The name of that particular technology is big data. I'm pretty sure you must have heard about it, right? Harsh Sharma and Anuj has asked, do we need to input the data to get desirable output via AI? Certainly, Anuj. So Anuj, AI mostly generates intelligence via two things. Either it uses data or it uses complex logics like fuzzy logic and something like this, right? So most of the cases, AI powered systems, they do use data only to gather and generate intelligence, right? Now coming to Harsh Sharma's question, sir, how is this algorithm working? It seems like you just use some library. Yes, Harsh. I have used the scikit-learn API. The name of the library is scikit-learn. It has been created by Google. The name of the algorithm is random forest, right? Now, when I teach random forest, it actually takes me 3 classes. And generally the classes that I do have, the timeline of that is around 4 hours. So to actually teach what random forest is, I actually need 12 hours, right? Because it involves a lot of statistics. But still, if you want to learn it, I can tell you the names of the topics that you should be aware about if you want to know how random forest works. Okay, so there is something called Gini index. I'll write the names of the topics here. You can search it on YouTube or you can search it on the internet portal, right? You search what is Gini index, search what is entropy, search what is a cost function, search what is a cart cost function, and search what is an error methodology. Machine learning. So if you can, Google and get a brief idea of what these topics are, this will involve certain formulas, and also learn about ensemble technique. Ensemble technique, primarily bagging. There are certain ensemble techniques like bagging, boosting, stacking, things like that. Right? So Anuj asked, what exactly is the purpose of AI in real world? Couple of purposes, Anuj. Humans have a limitation because humans are not very good at repetition. But AI, since it is a system which is powered by computer, it will not make the same mistake which humans are supposed to make. I'll give you a real world example, potent example. Let's say that you are a sniper, okay? Or let's say you are an army man with a gun. And let's say that there is a terrorist, you can spot him because you have binoculars. And the terrorist is actually hiding inside an enclosure. And the terrorist is in the close proximity of civilians. So certainly not every shooter in the army or not every army personnel and certainly not you are the best of the shooters. Certainly you are not an Olympian who is, who's got a gold medal in shooting. So you will not take the risk of firing the bullet because the terrorist is actually surrounded by a lot of civilians. But today what has happened is we can use something called object detection, right? Please Google object detection to know more about it. So satellites use object detection, and drones, fighter drones, use object detection to primarily target a spot, and they can hit that spot with a certain precision, right? So object detection is something that humans are generally pretty bad at when there is a real world situation, but AI can excel at that. I will give you a couple more examples. Let's say that you are a small startup and you have around 10,000 customers, like Zomato. So I live in Gurgaon, and Zomato is in Gurgaon only. Its office is on Sona Road, Gurgaon. And Zomato is a small startup of 300 employees only because it is still in the funding stage. They have just recently raised their IPO. So certainly if Zomato is working for 10,000 people, it is, delivering lakhs and lakhs of orders simultaneously. Certainly out of those orders, some orders will raise request. Sometimes the food is not proper. Sometimes you have certain complaints. So Zomato is not a big company that it can create a whole customer service division just to serve complaints. It is not that big of a company. They don't have that much capital. So what they do is they kind of create a smart chatbot. I don't know whether you have used Zomato or not, but Zomato does use a smart chatbot. So initially, unless and until your query is very difficult and it is very big, initially for all the customer queries, it is actually a chatbot, which is understanding your demand, which is understanding your complaint and trying to answer it in a proper way or an appropriate manner, right? So multiple examples, and this is really the thing of the future, coupled with quantum computing and big data. If you want to make a career in AI, certainly I can promise that it is not going to be easy. The road ahead is not easy because there are a lot of things you need to master. You need to master mathematics, you need to master programming, and you also need to master domain expertise, but it is also very rewarding, right? So you will be at the pinnacle of computer science career if you are somebody who can write AI, if you are somebody who knows about AI. So thank you very much, guys, for the questions. The questions were quite thought-provoking. I am pretty sure that my answers would have also made you aware about the techniques and the processes of AI. So thank you very much for being with me. And it is a Sunday evening. So I bid you goodbye now, and have a good day.
Thank you so much. Thank you so much, Rahul sir, for giving us a precious time. And once again, thank you all for your participation. Thanks.